Hey everyone, it's Mr. Canfield for BC Calculus. We're in chapter 15. I'm going to start with example 2 because I did example 1 essentially in my other video. So I'm going to walk through step by step how I'm going to find my different approximating polynomials. Okay. So if I want to find p of x, so remember that p of x, it says we need to get fourth degree, so we'll get all the way there. So that's going to mean I need to take 4 derivatives of the, or 3, 4, 12, 100, we'll get there. We need x to the 4th by the end. Yeah, 4 derivatives. So, and we are also going to be plugging in our center to each of those derivatives. And then we just follow the Taylor series formula, which is in your book on page 79. And it'll always work like that. So it's a shortcut to, instead of having to get it by like figuring it out each piece at a time. So here we go. Well, I may as well just plug it. Let's see, if I plug 2 in here, I get ln of 2 minus 1 is 1. And so remember, that's saying e to what power gets me 1, and that is the 0th power. So I get 0 for my very first term. And then now I can start taking derivatives of this. So f prime, let's see, f prime is going to be 1 over the insides, right? And then f double prime. So since this is the first one that we're doing like this, I'm going to just peel back the curtain a little bit, but it's negative 1 over x minus 1 squared. And the way that I did that so quickly was I remembered that this is really saying x minus 1 to the negative 1. So you might actually prefer to leave it like this and then say, so then this is negative 1 x minus 1 to the negative 2. And chain rule does apply, but what's the derivative of the inside? It's just 1, so it doesn't change anything. So then f triple prime is going to be, and this is where, like, you know, which of these formats are you going to prefer? It's going to be 2 over x minus 1 cubed, and that's because we do negative 2 times negative 1, which is positive 2 x minus 1 to the negative 3. So then negative 6 x minus 1 to the negative 4th is going to be our next one. Or we could say negative 6 over x minus 1 to the 4th. And here's the great thing, though. When I plug in 2 for all of these, x minus 1 turns into 1. So that means that the numbers that we get out, so we got 0 out for our first one. We'll get 1, negative 1 over 1 squared, 2 over 1 squared, negative 6 over 1, or cubed, sorry, negative 6 over 1 to the 4th. So we have 0, 1, negative 1, 2, negative 6. Those are our coefficients, and all we have to do is write the Taylor series formula, which says p of x is a naught plus a1 x minus c. And so you might have noticed I almost just wrote x. I'm so used to just writing x instead of x minus our center. And for brevity, secretly, that's actually happening. And even this first term has x minus c to the 0 over 0 factorial. It does secretly have that stuff there too. We just don't normally write it because x minus 1 to the 0 is 1, and 0 factorial is, spoiler alert, is 1. We're gonna find out why that's true a little bit later, because that's a bizarre fact. So a sub 2, 2 factorial to the 2, like that's all we're doing. So all I gotta do now is say, okay, what did my polynomial approximation is, this time I'm gonna write the 0 just again, for brevity. Am I even using that word right? No, not really. It's often used with the word clarity, but it says concise and exact use of words in writing or speech. So I guess exact. Maybe I was being a little bit more exact, but anyway, I don't know English. Okay, so let's see. A sub 1 was 1, and then our center was 2, right? Plus a sub 2, oh, I guess that's right, minus. So minus 1, which is going to be x minus 2, and then squared over 2 factorial, which is just 2, but I'll write 2 factorial here. We're going to see something really interesting with this problem. Let's see, and then we need the third degree, which is 2. X minus 2 to the third over 3 factorial, and then minus 6, x minus 2 to the fourth over 4 factorial. Okay, so check it out. I'm gonna do a little bit of simplifying. I'll show you the amount of simplifying that I expect from you. The 0 I would expect you not to write. So you would typically write this like this. So that's 2 times 1 is 2. 3 times 2 times 1 is 6, right? So this is 2 over 6, which is 1/3. So I would write as x minus 2 cubed over 3. It's like 1/3. And then 4. So 4 factorial is 4 times 3 times 2 times 1, which is 24. 6 over 24 is a quarter. So this would be our 4th degree Taylor polynomial centered at 2 for the natural log of x minus 1. And just a reminder, conceptually, the whole point of this is if I wanted to find out, like, let's say I wanted to know what ln of 0.5 was. If I wanted to know what ln of 0.5 was, I could, oh wait, no, this is centered at 2. So I would want a value close to 2. If I wanted to know what like ln of 2.1 is, then I could use this. Well, ln of 2.1 minus 1. So that would actually give me ln of 1.1. But like, if I wanted to find a value of this function somewhere around 2, I can either find this, which is going to be challenging, and like doing this by hand is essentially impossible, unless we transform it into this Taylor polynomial, and this would give us an approximation that is pretty accurate because we went out to 4 derivatives. The more we go, the more accurate it is. You can keep on making it more and more and more and more accurate. Okay, so I stumbled a little bit over my words. I hope that's a helpful explanation. So, all right, these ones talk about Maclaurin polynomials. So, a Maclaurin polynomial is just a Taylor polynomial centered at 0. So if I want to find a Maclaurin polynomial of sine of x, he says find all the, no, just do it, just do it. So we know f of x is sine of x. So then f prime is cosine. All right, I'm just going to go, so here's 0, 1, 2, 3, 4. These are my different derivatives. I don't feel like writing f, etc. So negative sine, negative cosine, back to sine, etc., etc., etc.